Lysergic acid and its derivatives. Lysergic acid proved to be a rather unstable substance, and its rebonding with basic radicals posed difficulties. In the technique known as Curtis's synthesis, I ultimately found a process that proved useful for combining lysergic acid with amines. With this method, I produced a great number of lysergic acid compounds. By combining lysergic acid with the amino alcohol propanolamine, I obtained a compound that was identical to the natural ergot alkaloid ergobenzine. With that, the first synthesis, that is, artificial production, of an ergot alkaloid was accomplished. This was not only of scientific interest as confirmation of the chemical structure of ergobenzine, which was valuable in obstetrics. After this first success in the ergot field, my investigations went forward on two fronts. First, I attempted to improve the pharmacological properties of ergobenzine by variations of its amino alcohol radical. My colleague, Dr. J. Pyer, and I developed a process for the economical production of propanolamine and other amino alcohols. Indeed, by substitution of the propanolamine contained in ergobenzine with the amino alcohol butanolamine, an active principle was obtained that even surpassed the natural alkaloid in its therapeutic properties. This improved ergobenzine has found worldwide application as a dependable uterotonic hemostatic remedy under the trade name Methergine, and is today the leading medicament for this indication in obstetrics. I further employed my synthetic procedure to produce a new lysergic acid compounds for which uterotonic activity was not prominent, but from which, on the basis of their chemical structure, other types of interesting pharmacological properties could be expected. In 1938, I produced the 25th substance in this series of lysergic acid derivatives, lysergic acid diethylamide, abbreviated LSD 25 for laboratory usage. I had planned the synthesis of this compound with the intention of obtaining a circulatory and respiratory stimulant, an analeptic. Such stimulating properties could be expected for lysergic acid diethylamide because it shows similarity in chemical structure to the analeptic already known at that time, namely nicotinic acid diethylamide, or choramine. During the testing of LSD 25 in the pharmacological department of Sandoz, whose director at the time was Professor Ernst Röthlin, a strong effect on the uterus was established. It amounted to some 70% of the activity of ergobenzine. The research report also noted, in passing, that the experimental animals became restless during the narcosis. The new substance, however, aroused no special interest in our pharmacologists and physicians. Testing was therefore discontinued. For the next 5 years, nothing more was heard of the substance LSD-25. Meanwhile, my work in the ergot field advanced further in other areas. Through the purification of ergotoxin, the starting material for lysergic acid, I obtained, as already mentioned, the impression that this alkaloidal preparation was not homogeneous, but was rather a mixture of different substances. This doubt as to the homogeny of ergotoxin was reinforced when in its hydrogenation, two distinctly different hydrogenation products were obtained, whereas the homogeneous alkaloid ergotamine under the same condition yielded only a single hydrogenation product. Extended systematic analytical investigations of the supposed ergotoxin mixture led ultimately to the separation of this alkaloidal preparation into three homogeneous components. One of the three chemically homogeneous ergotoxin alkaloids proved to be identical with an alkaloid isolated shortly before in the production department, which A. Stoll and E. Burkhardt had named ergocristine. The other two alkaloids were both new. The first I named ergocornine, and for the second, the last to be isolated, which had long remained hidden in the mother liquor, I chose the name ergocryptine. Later, it was found that ergocryptine occurs in two isometric forms, which were differentiated as alpha and beta ergocryptine. The solution of the ergotoxin problem was not merely scientifically interesting, but also had great practical significance. A valuable remedy arose from it. The three hydrogenated ergotoxin alkaloids that I produced in the course of these investigations, dihydroergocristine, dihydroergocryptine, and dihydroergocornine, displayed medically useful properties during testing by Professor Röthlin in the pharmacological department. From these three substances, the pharmaceutical preparation hydrogene was developed, a medicament for improvement of peripheral circulation and cerebral function in the control of geriatric disorders. Hydrogene has proven to be an effective remedy in geriatrics for these indications. Today, it is Sandoz's most important pharmaceutical product. Dihydroergotamine, which I likewise produced in the course of these investigations, has also found application in therapeutics as a circulation and blood pressure stabilizing medicament under the trade name dihydroergot. While today research on important projects is almost exclusively carried out as teamwork, the investigations on ergot alkaloids described above were conducted by myself alone. Even the further chemical steps in the evolution of commercial preparations remained in my hands. That is, the preparation of larger specimens for the clinical trials, and finally, the perfection of the first procedures for mass production of methagreen, hydrogreen, and dihydroergot. This even included the analytical controls for the development of the first galenical forms of these three preparations, the ampules, liquid solutions, and tablets. My aides at that time included a laboratory assistant, a laboratory helper, and later in addition a second laboratory assistant and a chemical technician. The solution of ergotoxin problem had led to fruitful results, described here only briefly, and had opened up further avenues of research, and yet I could not forget the relatively uninteresting LSD-25. A peculiar presentiment, the feeling that this substance could possess properties other than those established in the first investigations, induced me, 5 years after the first synthesis, to produce LSD-25 once again so that a sample could be given to the pharmacological department for further tests. This was quite unusual. Experimental substances, as a rule, were definitely stricken from the research program if once found to be lacking in pharmacological interest. Nevertheless, in the spring of 1943, I repeated the synthesis of LSD-25. As in the first synthesis, this involved the production of only a few centigrams of the compound. In the final step of the synthesis, during the purification and crystallization of lysergic acid diethylamide in the form of a tartrate, I was interrupted in my work by unusual sensations. The following description of this incident comes from the report that I sent at the time to Professor Stoll. Last Friday, April 16, 1943, I was forced to interrupt my work in the laboratory in the middle of the afternoon and proceed home, being affected by a remarkable restlessness combined with a slight dizziness. At home, I lay down and sank into a not unpleasant intoxicated-like condition characterized by an extremely stimulated imagination. In a dreamlike state, with eyes closed, I found the daylight to be unpleasantly glaring. I perceived an uninterrupted stream of fantastic pictures, extraordinary shapes with intense kaleidoscopic play of colors. After some 2 hours, this condition faded away. This was altogether a remarkable experience, both in its sudden onset and its extraordinary course. It seemed to have resulted from some external toxic influences. I surmised a connection with the substance I had been working with at the time, lysergic acid diethylamide tartrate. But this led to another question. How had I managed to absorb this material? Because of the known toxicity of ergot substances, I always maintained meticulously neat work habitats. Possibly a bit of the LSD solution had contacted my fingertips during crystallization, and a trace of the substance was absorbed through the skin. If LSD-25 had indeed been the cause of this bizarre experience, then it must be a substance of extraordinary potency. There seemed to be only one way of getting to the bottom of this. I decided on a self-experiment. Exercising extreme caution, I began the planned series of experiments with the smallest quantity that could be expected to produce some effect, considering the activity of the ergot alkaloid known at the time, namely 0.25 milligrams of lysergic acid diethylamide tartrate. Quoted below is the entry for this experiment in my laboratory journal of April 19, 1943, at 4:20 in the afternoon. 0.5 cc of 1/2 promil aqueous solution of diethylamide tartrate orally equal to 0.25 milligram of tartrate, taken diluted with about 10 cc's of water, tasteless. 5 in the afternoon, beginning dizziness, feeling of anxiety, visual distortions, symptoms of paralysis, desire to laugh. Supplement of April 21st. Home by bicycle from 6 p.m. to around 8 p.m. Most severe crisis. See special report.